Alright, section 6.8 is one of my favorite sections because I think it's one of the most useful and applicable sections of division, and that is looking at proportions. The definition of a proportion is a statement saying that two fractions are equal. So we can think about like 1/2 equals 4/8. So here's a statement stating that two fractions are equal. This one is really easy for us to see because I know that, hey, I multiplied this by 4 and I multiplied this by 4, or vice versa. I divided this one by 4 and I divided this one by 4. So I did the same thing to one side and it became the other one so that I know they're equal. So let's look at this statement here. And you can ask yourself, is this a proportion? I have two fractions, I'm stating they're equal. Are they actually equal? So ask yourself, 9 to get to 30, what would I be multiplying by? And 12 become 40, what would I be multiplying by? This one is definitely not as easy to see as the first one. So ask yourself, how could I figure it out? What you should be thinking is, okay, 9 times something equals 30. And likewise, 12 times something equals 40. Okay? So what you're actually going to do to solve for this times something, we're going to divide by 9. So 30 divided by 9, I get 3.3. 4 is turned into a fraction, 3 1/3. Okay, so I multiplied by 3 1/3 to get to 30. So what about the 12? Divide by 12, divide by 12. So 40 divided by 12, again, same number. So I multiplied by 3 1/3 here also. Okay, so did I multiply by the same number to get 9 to 30 as I did 12 to 40? Yeah, I took 9 times 3 1/3 and it became 30, and I took 12 times 3 1/3 and I got 40. So in other words, did I do the same thing to this fraction to become this fraction? Just as I did here, I did the same thing to become this fraction. Okay, so that's the really important part of proportions, is understanding that there is a multiplicative rate that gets this whole fraction to become this whole fraction, even if it's not easy to see, like this one here. Okay? This happens to be quite a bit of work, though, to figure out what is that number. Yeah, it was both 3 1/3, 3 1/3. So there is actually an easier way to check to see if it's actually equal. Okay? And I think you've heard this before. It's called cross multiplying. So I'm going to go back and take this 9/12 equal to 30 over 40. Okay, and you can only cross multiply through an equal sign. So I'm going to multiply the 40 times 9, 360. Okay, and then 12 times 30, 360. 360 equals 360? Yes, of course it does. So this is a much more efficient way to find if the proportion is actually equal than trying to figure out what that actual rate is, okay? So again, the understanding is that this fraction was multiplied by the same thing to become this fraction, but to check to see if they're actually equal, cross multiplication works really slick and fast. Okay? So let's actually use a story problem to see where proportions are helpful. Example 1 in your book is saying a motorist traveled 283.5 miles on 9 gallons of gas. With the same driving conditions, how far could the car go in 14 gallons of gas? Okay, so in this example, I know I could go 283.5 miles on 9 gallons of gas. Okay, so here's one fraction. I want the same driving conditions, so in other words, I'm going to make an equal fraction, but this time I'm going to look at 14 gallons of gas. Okay, I kept gallons with gallons because I want this whole fraction to be multiplied to become something else, and I'm not going to be able to get miles to become gallons. Okay, so I don't know what this is, so I can go ahead and use my cross multiplication. So I'm going to do 14 times 283.5. That was this cross multiplication. Is going to equal 9 times x. Because they're a proportion, I know these are going to be equal. So now I just have a nice equation to work with. Okay, so x equals 441, and that was up here, so that was my miles. So does that make sense? 9 gallons will get me 283 miles, 14 gallons get me 441. I think that makes sense. The way I set this problem up originally, I did this rate is equal to this rate. Okay? The thing with proportions is you can also set up a ratio equal to a ratio. Okay? So this was rate equal to rate, but we can do the same exact problem as a ratio equal to a ratio. Okay? So if we go back to this information, okay, and I want to set up a ratio, so that means in my fraction I want the same units. So I'm going to do 9 gallons over 14 gallons. Okay, so there's my ratio. And I'm going to set that equal to the other ratio in my problem, which would be 283.5 miles. And here are the miles that I don't know. Okay, again, we can just cross multiply. So I get 9x, and then 14 times 283.5. And if you notice, this is the exact same equation that I have when I set it up rate equals rate. Okay? So it doesn't matter if we set up rate to a rate or ratio to a ratio, because after you cross multiply, you're going to get the same two products. Okay, so you'll get the same answer. The only thing you have to make sure is that you're consistent. Okay, so with the rates, I have to do miles to gallon, miles to gallons. I couldn't do miles to gallons, gallons to miles. Then with the ratio, I just have to make sure I do either small to large and small to large, or large to small, large to small, but you couldn't flip and do small to large, large to small, okay? So you have to be consistent in that manner, okay? We can do this without story problems also. Example 3 has a proportion. 3g plus 4 over 5 equals 4g minus 8 over 4. Okay, So as we look at this problem, I see one fraction equal to another fraction. So my cross multiplication will be an easy way to go ahead and solve this. Okay, so I will multiply these first. So 4 times 3g plus 4. And then 5 times 4g minus 8. So I will distribute. And now it's just a two-sided equation that you know how to solve. I'm going to subtract 12g and add 40. So g equals 7. Okay, so if you ever see two fractions set up equal to each other, cross multiplication is always a way to solve them. And if you have story problem ratios, just remember that you can set up as one rate equals to another rate, or a ratio equals to a ratio, and you'll get the same answer.